Hello everybody, we're doing our video today in section 6.5, which is going to be how we graph equations from slope-intercept form. Now, we've looked at some of this already. We looked at rewriting the equations a little bit so that we get them in slope-intercept form, but here we're going to look at it in a more focused and deliberate way. There are going to be two forms of the equation that you can be provided with that are kind of recognized in math textbooks and among mathematicians that we'll discuss. The most common one, and the one we usually learn about first, and we already have learned about, is what we refer to as the slope-intercept form. And this one's very nice because when you have an equation written in this way, you can readily identify both the y-intercept of the line as well as the slope of the line. And using the line in this form, as we showed in the last section, we'll continue to show here, we were able to plot lines quickly and efficiently. Then there's another form of an equation that we can graph, which is called standard form. And to be frank, standard form is a fairly useless form. I mean, you can figure out what the slope is, you can figure out what the y-intercept is, but it's not very handy. So sometimes, though, you're going to be asked to find the equation of a line given some information, and oftentimes you're going to find the equation originally by putting it in slope-intercept form. But you may be then asked to rewrite the equation in standard form. So we're going to take a look at what that process looks like here. So let's just take a look at what a standard form of an equation looks like. So we're going to have, and this is going to be a capital A, and the capitalization is important, times x plus let me make that a capital B2, ax plus by equals c. Now, what you'll find here is what's the same and what's difference. What's the difference between these? Well, first off, let's just take a look that, first off, A and B, they have to be whole numbers, or I should say they have to be integers. And typically when we write something in standard form, A should be positive. If we're going to write something in standard form, we should not write A with a negative number. So if it happens to be negative, then we have to multiply the whole equation by -1 in order to get the A term positive. So A and B are going to be, and I should say not only A and B, but A, B, and C are going to be integers, and then the A term has to be positive. Unlike slope-intercept, you can have a fractional slope, you can have a fractional value of M, you can have a fractional value of B. So you're not restricted on the type of values you have for those. But for A, B, and C, they have to be integers, and specifically A has to be a positive number. All right, so if we take a look at what's on the same side of the equal sign, so if we take a look at the equal sign here, take a look at the equal sign here, we'll notice that we have some constant number without an x and y over here, just we have this constant number. That's not to say C directly corresponds with B, because sometimes we have to divide and that is going to change. But we do have the constant number that appears on the right. On the left-hand side, we have a y that appears. Now here the y is going to be by itself if we write it in a proper slope-intercept form. Here the y can have a variable with it, but the y is always going to remain on the left-hand side of the equation. So the one thing you want to kind of focus on and know that you're always going to have to do, if you go from slope-intercept form to standard form, or from standard form to slope-intercept form, the one thing that you're always going to have to do between going from one form or the other is you are going to have to move the x term. Okay, so now sometimes that x may be by itself, but there may be a number attached to it too. But when you go from slope-intercept form to standard form, or from standard form to slope-intercept form, know that we're always going to have to move the x in order to do so. So you're going to hear me talk about that as being a common idea when we go between the two forms. Now, there may be a little bit more to it than that. Okay, remember, the These have to be whole numbers here, so we may have to do some multiplying and dividing to make that happen. And over here, the y has to have a 1 in front of it. We can't have another number in front. So in order to make that happen, we may have to do some additional work based on that. So we'll take a look at these problems as they emerge, and we'll go ahead and actually start on the problem. So remember, we have two forms. Slope-intercept form, y equals the slope times x plus b. We've already learned about this. And then standard form, ax plus by equals c, where a, b, and c are integers, and a is going to be positive. Okay, let's begin to take a look at some problems here and take a look at that. So in question 1, we're asked to write the equation of a line with the given slope and the given y-intercept. So if we have the equation of the line in this form, y equals m times x plus b, and they give us the slope and y-intercept, all we need to do is introduce this into the problem, which I'll do in the following way. Make sure everyone can see the problem. Oh, barely, but we can see it. Okay. So that's going to be y equals negative 2x, and I put this as a plus, and then negative 1 over 8. All right, so one thing I see from a lot of my students, and it must be the way they're taught somewhere along the way, that when you have a plus and negative, adding a negative is the same as subtracting, so let's consolidate that down to just one symbol. So we're going to have y equals then negative 2x minus 1 over 8. And now we have the equation of that line written in the slope-intercept form. Okay. Take a look at the next one. It's number 2. Write an equation of the line with a given slope m and b. And if you'd like to try this for yourself, just know that you're going to have to plug m and b in for that. You can try pausing the video and then seeing what you get here. Either assuming you restarted the video or just want to keep going forward to see what happens with this. We're going to put 0 in for m, and then we're going to have plus, and this is going to be a negative 3 here. So we're saying the slope is 0. Try to think about what kind of line has a slope of 0. We've talked about this in a few of the sections before, and you remember the line that has a slope of 0 is going to look something like, if I can show, it's going to be kind of like this. So it's going to be a horizontal line. And we should get, when we do this, 0 times x is 0, plus the negative is going to be minus 3, or y is going to equal negative 3. So it's going to be a horizontal line that's going to go through the value, going to go through the y-axis at negative 3. Okay. Let's take a look at the next questions. It tells us in this problem here to use the slope-intercept form to graph the equation y equals 6x plus 3. So when we use the slope-intercept form to do this, what we've got is we can identify the value of b. Remember, b is where we begin, and that's going to be equal to 3. And where we begin is always on the y-intercept. Remember that the slope tells us how to move, and because the slope is 6 here, I can write this as 6 over 1. The 1's going to tell me how much I move to the right, and then the top number is going to tell me either to move up if it's a positive slope, or to move down if it's a negative one. So from here, what I can do is I can take this 3 that I have here and plot it on the y-axis, because I always begin on the y-axis based on the value of b. And then from here I can count off at least one other point where I'm going to move to the right one, but because this is positive, I'm going to move up 6. So I'm going to count to the right one. I'm going to move up 1, 2, 3, 4, 5, 6. And that's going to be the basis for my line. Now, if you want to try to work the other way and maybe plot maybe 1 or 2 points this way, you go to the point to the left and the right, or to the right, and then work your way left. So go to the left one and then down 6. Let's repeat that. Go to the left one and down 6. It's going to bring us down here. Do that one more time. Go to the left one and down 6. And you should see that, in fact, yes, we do get some points that comprise a straight line. Use a nice pencil I have here to generate this line. Not perfectly drawn, but should be good enough to illustrate the point here. So here's the graph of the line y equals 6x plus 3. Sometimes it's often appropriate to go ahead and actually put the equation of that line on here, but you're not going to be asked to do that in MyMathLab. But it's often appropriate to go ahead and show the label of what equation yields this line in the Cartesian coordinate system. All right, so let's go and take a look at the next problem. It says use the slope-intercept method to graph the equation 4x minus 5y equals 20. So we talked about a little earlier, going back to this idea, I'm going to cover this up for a second, that if we have an equation in standard form, that we want to convert it to slope-intercept form to do this problem. In order to do that, I mentioned that we would have to move the x. So we have to make sure that we're going to move the x term from one side to the other. But we also want to make sure that we get the 1 by itself, because that's a necessary part of an equation being in slope-intercept form. So bearing those two things in mind, the first thing I'm going to do in this question, I'm going to rewrite this problem here, 4x minus 5y equals 20, is I'm going to go ahead and move the x to the other side. And like I've shown you in class before, move that to the other side and take the opposite sign of it. So that's going to be negative 5y equals negative 4x plus 20. Pay special attention to the fact that I did not write this as 20 minus 4x. Remember, what am I going toward? I'm attempting to write this in the form of y equals the slope times x plus the y-intercept. So I want to try to put the term that has the x as the first term, and then the number that's by itself as the second term. From here, remember, we're close to this form, but we don't have y by itself. So as a final step, that's going to mean that I'm going to take each term and I'm going to divide this by the number next to y, which is going to be, in this case, negative 5, negative 5, negative 5. And when I'm done here, this is going to give me the y I'm looking for, because negative 5 divided by negative 5 is 1. Negative 4 divided by negative 5 will give me 4/5 x. And then 20 divided by negative 5 is going to give me negative 4. And now that we have this, we have this equation written in slope-intercept form, where m is equal to 4 over 5 and b is equal to negative 4. So go ahead and make a note of that over here. We have b is equal to negative 4, and then our slope is equal to positive 4 over 5. With that information now, after we converted from standard form to slope-intercept form, we can now use these two values to go ahead and plot the point. We're going to begin on the y-axis at negative 4. From here, we're going to use the slope to tell us where to go. If we have a slope of positive 4 over 5, that means I'm going to go to the right 5, and I'm going to go up 4. So I'm going to go to the right 5, I'm going to go up 4. Then go to the right 5, I'm going to go up 4. And I now have 3 points that are going to give me a line that I generated using this slope and y-intercept based on my change of making the equation from standard form to slope-intercept form. And remember, when we convert an equation from standard form to slope-intercept form, you're always going to move the x from one side to the other. That's also true if you're converting from slope-intercept to standard. The first step should always be move the x. Afterwards, then, you want to consider other things like what number should be in front of the y, what kind of value should you have for a and b, and so forth. In this case, because the y was not by itself, we had to divide everything by negative 5 to get y by itself to put it in slope-intercept form. But our first step was to move the x to the other side. Okay, let's take a look at another problem here. Okay. This is kind of a word problem now. So it says find an equation of line with slope of m equal 2 that passes through the point 4, 4. Okay? Write the equation in the form. Now, in your video, my guess is they're going to show something which is called the point-slope form of an equation. In the point-slope form, and I'll talk about this, but I usually don't use it. I find that students have a hard time memorizing all the different forms. It looks something like this. X minus x1, or sorry, not this. Y minus y1 is equal to m times x minus x1. We're going to get the value of x and y and m, and we plug it in, and eventually it gives us an equation. I prefer to try to keep things a little more consistent. What we're going to do for this approach is, and if you like this, you can use it, but you're not going to see me talk about it much in class. I prefer to continue working with y equals the slope times x plus b. Because when we want to find the equation of a line, the two pieces that we're usually looking for are the slope of the line and then whatever the y-intercept of the line is. In question 5, they provide us with the slope. They tell us that m is equal to 2. However, we don't know the value of b. That's a question. However, they do give us a point. So what information do they provide? They tell us that m is equal to 2, and in the point where the point is 4, 4, x is going to equal 4, and y is going to equal 4. So I obtain these two values from the point here. So what I'm going to do now is, in place of y and m and x, I'm going to put these values in. So now I'm going to have 4, that's the y value, equals 2, that's the m value, times the x value, which is 4, then plus b. So I'm going to find what the b value is. So I'm going to have 4 equals 2 times 4, or 4 is equal to 8 plus b. Once I have that resolved, I try to get 8 by itself, so I'm going to move 8 to the opposite side. So here's a case where you want to leave the b over here. Don't mess around with it. So I'm going to write this as 4 minus 8 equals b, or b is going to equal negative 4. Well, now we know what the y-intercept of the line is. We know it's negative 4. So what can we do with that? We can use the slope and the y-intercept of the line. We're going to sub that into y equals mx plus b. And to get the equation of the line in slope-intercept form, we're going to go ahead and sub in 2 times x plus negative 4. And then this will just simplify to y equals 2x minus 4. So that's getting the equation in slope-intercept form. However, in the question, they're not asking for the equation in slope-intercept form. They're asking for the equation in standard form. And because of that, remember, when you're going from either slope-intercept to standard or standard to slope-intercept, the one thing you must always do is you must move the x. You must move the x term. So when we move that, let's see what happens. So when I bring this like 2x to the opposite side, that's going to give me negative 2x plus y equals negative 4. Now, there's one other thing we have to consider for this. In the form of the equation, and I'll see if I can kind of write this to the side here, ax plus by is equal to c. In the equation of that form, we have to have the a value positive in that form. Because the a value is negative here, what I need to do with this value now, and I'll move this up just a little bit, is I need to multiply this through by negative 1. And because of that, that's just going to cause all the signs to switch so that I get 2x minus y is equal to 4. And I believe that's going to be, you know what I just noticed here, guys? In the video, they seem to have this as the correct answer, but they don't seem to have the negative moved. Don't know why that is, but maybe they're not going to be insistent about this. Okay? If they're not, that's okay. And you can just leave the answer as you got it here, and you should be able to be happy with that. I'm going to make a second video to follow up a little more work with this. I will return with a part 2 to this video later. Thank you.